Log stuff, when we did this last year, we wrote it just ever so slightly. We said it was y equals log base b of x, so b to the x equaled y. Remember that?
Yes.
They don't use base, they don't say base b anymore, they say base a.
Why?
They do it to annoy you. So their definition here, excuse me, is log y equals log base a of x. What's that? I'd rather you just, if you keep it in terms of the way that the pre-calc book uses it, that way when you go back and you look at it, you don't get mixed up. You know, if that makes sense? So then that just basically stands for then x is going to equal a to the y. That's how the logarithm stuff works. And that's how they're going to write these things for you as you go through it. I know from last year in Algebra 2, once we got over the hump of the idea of what logarithms allowed you to do, they were really easy to work with. I think the trickiest part was the condensing or expanding some of those parts when we got to it. But for the most part, a lot of the logarithm stuff was pretty straightforward. Even the equation stuff, where you just basically were changing the base formula in your calculator. You guys all had the log base b button, you can just change the bases and do all the solvents and all that stuff. So it was nothing really all that crazy. So here we just say it is by f of x equals log base a of x. That's just how this one's written, instead of base b. I don't know why they changed it, but they did. So what we're going to be able to do then is, these guys are, why didn't this show up very well? I'm sorry that my scan copy didn't look as clean.
Yeah, it showed up really weird.
It was a little blurry on it.
It wasn't like blurry, it was like,
At least it's not as crooked as chapter 2 was. Chapter 2's was very crooked on mine. Oh well. So here's what we're going to do. We're going to evaluate logarithms by remembering what they meant in terms of powers and stuff like that. We're going to rewrite them, substitute in values, and simplify them out. And I think a lot of, like I said, a lot of this stuff is review.
do you have any geometry classes after this?
Nope.
Do you have any classes after this?
Yeah. So we have y equals log base a of x, which means a to the y is x. Excuse me. So if I want to start with this here, log base 2 of x when x is 32. All we have to do is just rewrite it. That means log base 2 of 32 is the same as saying 2 to what power equals 32. It's fine. What you're doing here is you're trying to figure out what power, 2 raised to what power is 32. That's what logarithms do. Remember when you did this, 2 squared is 4, 2 cubed is 8, but 2 to what power is 6?
2 point something.
Correct. I'm glad you didn't say 2.5. So.
I was thinking about it, but then I changed my mind.
Yeah, logarithms allow you to figure out 2 to what power gives you 6. That's what these things do. Chemistry. You use logarithms a lot.
Well,
Yeah.
probably this week.
I know AP Chem uses them a lot. So my wife came home about a week or 2 ago, and she said, "What the hell's with logarithms? And why do we need them in chemistry?" They use them in chemistry. Let's try another one. Y is 5. Yeah, so my answer here would be, a lot of these are going to be ones you're going to be able to figure out in your head. Like I said, calculator, non-calculator. You'd have to have a calculator to figure out 2 to the x is 6, but 2 to what power is 32? I think you could probably figure it out. I usually don't go higher than fives as far as exponents are concerned. Like 5 cubed might be about as maybe 5 to the 4th power. That's about as big as I want you guys to try to be able to do in your head. I mean,
That's a lot.
well, how much is, if you have 5 sets of $1.25, how much money do you have?
$5.05.
Very good.
Okay,
And
I
it's
was,
calculator.
No, I'm
Oh,
not.
yeah. And what I'm sitting here is, if you think about it, if you know what 5 cubed is, right? What's 5 squared? Times 5. 125. So 5 quarters is $1.25. If I go 5 to the 4th, that means I have one more set of these, 5 sets of this.
yeah.
So this much is $5, and this much is another $1.25. So it's okay. That's about maybe six cubed. You know, I don't.
6 cubed is 36. No, oh, that's square.
It's. I mean, obviously you know what 6 squared is,
I'm done now.
but
No
you can
more.
multiply that again by 6 if you had to. Things like that. I don't try to go overboard with trying to get you guys crazy values that you're not gonna be able to figure out. 2s to like, you guys should all know your 2s through about 6 or 7, right?
Sure.
2 to the 5th is 32. 2 to the 6th would be.
64.
2 to the 7th would be.
128.
2 to the 8th. 256. We're just doubling it each time, right? You're just doubling
Well,
it.
2s are easy.
Also, our 3s.
Sure. You know me, Mr. Murphy.
Log base 3 of x when x equals 1. Excuse me. Well, that means 3 to what power is 1? 0. Remember, 0. Anything with a 0 property is always 1. So in this case, the y value would be 1. Let's put the other one. So if I have log base 4 of x when x is 2, that means log base 4 of 2, so 4 to what power is 2? 1/2, very good. 1/2 power is the same thing as taking a square root. If you said 1/3 power, what would that be? A cube root, good. So in this case, well, 1/2 power is the same thing as a square root. 1/2 power is a square root. So the other one. You have log base 10 of x when x is 1 over 100. Is this the same thing as saying this?
Yeah.
If you ever see log with no base, it's always implied that it's base 10. The button on your calculator, just the regular old log button, that's automatically base 10. All right, that'll be a base 10. Okay. Oh, actually, if you hit that log button, it's going to force you to put in a base 10. Never mind. I think on the old calculators, you'd have to, if you hit log, it just goes automatically 10. All right. So log base 10 of x is the exact same thing as saying log of x. They're equivalent. So this means then 10 to what power is 1 over 100?
Is that 1? Is that no.
It's a 1. It's a 1.
Doesn't.
Oh, I see what you're saying. I didn't notice that. There you are.
So would it be to the
Very good. Remember, negative exponents just turns things into fractions. Negative exponents just means you're not happy in the numerator if you're up top. So you move it and you square it, so you get 1 over. No. It would be, the y value here would be negative 2. Because this would be the same as 10 to the negative 2 is 1 over 10 squared, which is 1 over 100.
Right.
So you get negative 2 for this value. So you just get accustomed to remember, it's the idea of, do I remember how to manipulate numbers? A lot of the first couple of steps with logarithms work out to be. They don't get too crazy to get you to solve equations or any of that kind of junk yet. I mean, we'll get there, but if you guys remember when you solved a log equation, it was nothing more than pressing buttons on a calculator. There wasn't really a lot of craziness at all. Couple of properties then to remember. We are? I remember you were just waiting. Couple quick properties then. Oh, wow, this didn't show up very clean at all. Anyway, so log base a of 1 is 0 because a to the 0 is 1. Log base a of a is 1 because a to the 1 is a. Now, like I said, if you wrote that as log base b of b, remember that when you had the same bases there, it would logs disappear, you got 1, things like that. I don't remember those little shortcuts from last year. One of the shortcuts last year when we were simplifying logarithms is once you get the same bases within the logarithms like that, because this is a base here, log base a, and a here is a base with an exponent of 1. If those two bases want to be the same, it's always 1. And you'll see it with the next property here again. And like I said, a lot of this stuff is review. So log base a of a to the x is x. That's where this is kind of what Kadir was talking about. Why does that work? Well, since I've got two things with the exact same base, that exponent falls. Kind of out, they undo one another. You guys might remember that as something like this.
So you're going to do like 10 log.
What do you mean? Yeah.
10 log of x. Well, I'm saying, okay, 10 log base 10 of x. And that would be log of x, right?
Yeah, this is still just, this 10 here has nothing to do with it in here.
I thought that they were saying that
It's got to be this. It'd be log of x, excuse me. This would equal x because these two bases here are the same. Right? Nah, that's just the multipliers of scale. What'll happen here eventually is that you'll have problems like this. 3, oops. In my mind, I want to write and say 3. Eventually, we'll have this: 3 to the x minus 2 equals 7. Remember how to get that exponent to drop? You'd use that log base 3 for both sides because these bases wound up being the same, which allowed this to drop, and you get, and then so x would equal 2 plus log base 3 or 7, some crummy number. You're using these properties, which I know you guys did really well at last year. I remember this. I bet you did.
Miss Murphy, you know what I got.
I don't remember. It was a long time ago. Remember we called it exponentiating? I don't know if you remember that. You don't remember that?
I remember the word. but I
We'd
don't
log
remember
it,
what meant.
and then we'd exponentiate it if we had to. Second semester.
Oh, well,
Yeah,
then you
yeah.
Yeah, we did this week.
How did you do that? Wasn't that what I was saying? It's an A with and the log is.
But what you have to have, you were saying that it had to be this expo, the logarithm had to be up in the exponent. This is an exponent. Okay. What you were saying was 10 times the log. Then it doesn't matter. Here it's an exponent. So this has a base 10 with a logarithm with a base 10. That's why those two bases would drop. When it was a scalar up front, it really didn't make a difference. Because what we're going to be able to do with the equation stuff, I'm going to say if I can say 3. Thanks. In order to solve for x, you first of all do that. And then you'd have your log base 2 of x is 4/3. How do you get rid of a 2 as a base? Well, you have to exponentiate it by raising it up, which means this becomes an exponent here. So x would equal 2 to the 4/3. Things like that. I think that's what you were talking about.
That's pretty intense.
But we'll get there. And then the last one. Go, read it. Log base a of x equals log base a of y. If and only if. Remember that? If.
Should be if I F and O
Everyone in the class was just quiet.
All right, very simple properties. It's just remembering to get back into using them again. Hopefully it's not going to be so
Are
scary.
you making fun of me?
That's
Yeah,
right.
because if and only if.
You
so-
said the if was just the F.
Oh. Whoops. Well, that's where I went wrong.
So if we're working with the properties of logs again,
So is that equal 0?
excuse me. Yeah, anything that has log base of 1, we got to make sure that, remember the properties here, it's going to equal 0. Because a to the 0 is 1. Okay. So what would log base 4 of 1 equal?
1. No?
You just said.
Oh my.
Yes.
The board, Madeline.
Maddie, it's been a couple of
I
days off.
tried.
It's okay. You had a couple of days off. We'll give you a little bit of slack.
Okay, but didn't you say anything? Oh, never mind. Never mind.
All right. Log base root 7 of root 7. Log base root 7 of root 7 is 1. Those work out being the same. You're going to get 1.
I don't understand.
Is that E?
So that's where is the
C.
Remember it written like this maybe last year?
6?
Yeah.
Basic.
Oh.
It's the same thing.
The root 7 is 2.
Wait, what's
It's
As long as it's the same.
Yeah.
We wrote it as base B, base B. Pretty confident the right thing is in terms of A.
I can't see.
Yes, sir. I'm sorry, what's that? You get negative values. We don't deal with negatives in logs. You can have negative scalar and work itself through, but I don't think we want to put a negative
Is
log.
there eyes involved?
I don't remember ever seeing that before, to be honest with you. Yeah, because all of our everything's positive. X is greater than 0, A is greater than 0, and A is not equal to 1. It's always been positive. All right. And then the last one here, this is that exponentiation style. 6 log base 6 of 30 is what?
I'm not answering.
30.
That's a 20.
Oh, is it a 20? Wow. Well, if it was 30, it would be 30, but since it's 20, it's going to be
20.
You're mixing your twos and your threes up. I don't think that's like.
You're mixing your ones up.
It's okay. You had to do.
I had a couple of days off. What's that?
I heard.
Yeah, just, this is just
So let's use a couple of these properties to see if we can figure out some very simple log equations. All right. This is log base 3 of x equals log base 3 of 12. Let's solve for x.
yes.
Is it 12?
Yeah.
Yes.
I was gonna say that, and then I didn't want to be wrong again, so I didn't say anything.
Yeah. Now, what I want you guys to start to remember when you're dealing with properties and logarithms, if you remember from last year, to get x by itself, we had to either take the same log base on both sides, or what we would do is we would exponentiate both sides. In order for this to work, since you're started out with the log base 3, if I use this and it became an exponent to both sides, I get 3 to the log base 3 of x. This undoes it, which allows you to get x equal to 12. In essence, that's what we're doing here. But we're just saying, well, log base 3 of x equals log base 3 of 12. Well, in order for them to have the same log base to equal the same number, they have to be the same. All right. Same idea here. If I have log of 2x plus 1 equals log of x,
Wait, so you get a final answer, and then get x equals negative, right?
that's possible, absolutely. But you're not going to take the logs. Your a values are going to be positive, your x values are going to be positive for the log generic, for the generic rules here.
It's a final answer right now.
Correct.
Yes, it is.
So if I have that, for me, what's the base that you don't see?
The 10.
10. So I would exponentiate both sides to the 10. That allows those values to drop. You guys remember doing it that way? I hope.
No.
No, I honestly do not.
Sure.
At all.
Makes it seem easy, so.
So in this case here, you have variables on both sides, blah, blah, blah. What do you get for x?
Negative 1. Yep, there you go.
You get negative 1. How do I get negative 1? Subtract x, subtract 1.
Oh, okay, yeah.
Excuse me. And then the last one there, we write this down here. Well, that's not terrible. Log base 4 of x squared minus 6 equals log base 4 of 10. Since you have the same log base on both sides, if I exponentiate them again, I wind up with x squared minus 6 equals 10 plus or minus 4. We took a square root over an equal sign.
Yeah, that's what I'm saying. That was right.
Yeah, because what's negative 4 squared?
It's like that.
Yeah. You might get an extraneous. You guys remember what extraneous solution meant? Yeah, it's a solution that's a solution, but it might not actually work. You might get an error message. Okay, so that's possible. So you always want to just double check your answers.
Wait, how is it 4?
Add 6, you get 16. Take the square root, you get plus minus 4. To solve this equation, you add 6, so you get x squared is 16. Square root, you get x equals plus or minus 4. All right. I think the next one is graphing. I don't think I want to do that today.
I don't think we want to.
Yeah. I'm pretty sure the day 1 stuff gets us through the solving of the equation parts here. On the day, I think I'm going to split this one up a little bit. And not, since we're not worrying about our graphs yet.
So
Let's do this. Let's change it to,
You might first. Who are you? You.
yeah, I think this will still work for the every third part. Oh, no, we didn't do that. All right, sorry. We'll go through 30. We didn't do the graph, which is fine. And then. Do those 4 then also, okay? And then we'll worry about graphs, domain ranges, and natural log and tomorrow, okay? Is that okay? We'll still go every third, so it's what, 15 problems? Most of them are just quick properties, and then you have that last little 4, which is to solve the equation. All right?
Humanities.